All right, so one result, and it's called the effective annual yield. Now, the yield is an interest rate, and so it will behave a lot like the R that we pick out in our problems and convert to a decimal. So Y is a rate, and it will be written as a decimal, but usually we want to convert it to a percent. And what you will find in these calculations, is that the Y, which is the annual, you can think of it as the annual simple interest rate. When we have a compound rate, and let's say the rate is 5%, and we compound it like quarterly, the net interest, because of that compounding, will raise the actual yearly rate to something a little bit larger than 5. It might be 5.1%. It doesn't raise it a whole lot. It's not going to raise it from 5 to 10%, but the compounding factor raises it a little bit. And so if you're comparing two different rates, and one of them compounds interest daily and the other one compounds the interest quarterly, but they're different rates, to compare the two rates together, to really answer the question, which one of these funds or which one of these rates compounded the way it is actually going to give me the most money at the end of the year. And the effective annual yield is a way to convert both of the rates to a simple interest yearly rate, and then you can do the comparison that way. So it's always going to be the case that the effective annual yield is just slightly larger than R. So as an example, if I'll just say compounded daily. If the interest rate is 5% compounded daily, if that's what R is, then Y might be something like 5.1%, just a little bit larger. And here is the formula that we use to calculate the interest rate. As they say down here in this explanation, they're really going to take a look at what happens to $1. What does $1 convert to? And then you get $1, and then you're going to evaluate this, and you'll see how much larger the dollar is, but then you're going to subtract the dollar and just leaving the rate. So they kind of say that down here. But let's take a look at how it would work out in a couple of problems. Most of your problems are going to be like this. It says compute the effective annual yield. All right, so we're calling this Y, and I think our author calls it APY, annual percentage yield. But so when you see this, don't be surprised. I'm just going to call it Y. So maybe I'll just write it up here. Every author has a different way of representing these things. And then they want you to round the percentage to the nearest tenth of 1%. All right, so here's the example. All you need is the interest rate and the compounding factor. Compounded quarterly, remember, gives us, oops, that's an N. Gives us a compounding factor of 4 for quarterly. So let's write down our formula and plug in the right numbers. Notice that it's a little different than the compound interest formula in that the exponent here is not N times T, because we're doing a simple interest rate, which is based on 1 year. So T is 1, and so N times 1 is just N, and so it's left off. All right, so the first thing that you have to do is you have to convert the R to a decimal. And we've always done this. Move the decimal point 2 places to the left, and then take away the percentage symbol. And then N is just 4, we plug it in. So the annual yield is 1 plus 0.0679 divided by 4 to the 4th power minus 1. And the only thing left to do there is to punch it in on your calculator. So I think we can get it all in one line. 1 plus 0.0679 divided by 4, close the parentheses, and then raise that to the 4th power, and then subtract 1. Now remember, what you're going to see here is a rate, and it's in decimal form, so the last thing we have to do then is to convert it to the nearest percent. All right, so let's write this number down. Oh, there it is. Now, if we convert that to a percentage, then it would be, I moved the decimal point 2 places to the right this time, and then I would write 6.9648. Okay, and then the rest of it as well. And then at the end, throw in the percent symbol. So you're converting from a rate to a decimal, and then when you calculate, you convert from the decimal back to the rate. And then here it says round to the nearest 1/10 of 1%. So there's the 10th place in the percent. So if we round this one, we go back to the previous digit. Notice that it's larger than 5, so we round up to 9, and I guess we have 10. So we put 0 here and then up the next one by. So it's about 7%. The effective yield, what you're really earning in interest in 1 year is 7%. It's not this 6.79%. The compounding increases a little bit. All right, let me just show you a couple of calculations here. If instead of quarterly, we change this to monthly, then I would have to change the value of n in 2 places. I'd have to change the 4 to a 12 there, and I also have to change the 4 to a 12 there. So if interest was compounded monthly, would that change this number dramatically? Let's take a look. Yeah, it's now up over 7, but if we rounded it to the nearest 1/10 of a percent, we'd get the same thing, 7.0. It is a little bit bigger, but not a whole lot bigger. So the compounding factor doesn't increase that rate dramatically, just very slightly. And the larger the compounding factor, let's do another one. Let me change these 12s to 365. I have to change the n in both places, the denominator of the fraction inside parentheses and the exponent. So it'll look like this. Let's see how much larger than 7% it gets. Not a whole lot. Even that one, rounded to the nearest 1/10 of a percent, is 7%. But you can see that it's higher than our 2 earlier ones. So as the compounding factor goes up, the effective annual yield will go up, but not by a whole lot. Well, that's really the new stuff for today, right? And so we can practice these and come up with the same result. One other thing that I might want to show you, but first let's work this one out by this next one, part B here, by hand. And then I want to show you a calculator function that you can use as well. All right, so in this case, the R is 12.5%. So the very first thing we do, whenever we punch R's into our formula, we have to convert to the decimal version of that. So 0.125 is the decimal version of that rate. And the compounding factor, because it's compounded monthly, the n would be 12. All right, let's plug in the numbers. All right, we have the interest rate first. Errors that students make along the way is, they'll input one variable in a spot when they should have put a different value in there. But so whatever goes here goes in the exponent. These two are the same. And in this case, they're 12s. And there's only a small set of numbers that we put in that spot. 4 for quarterly, 1 for annually, 12 for monthly, 365 for daily. All right, so I know before I even hit any buttons on my calculator, I'm going to get something a little bit higher than 12.5%, maybe 12.8% or something like that. All right, so that should do it. And then hit enter. 0.132416046. All right, now remember, there's nobody going to be there that tells you that you have to convert this back to a percentage, but usually we want our interest rates. And Y is an interest rate. It's just kind of the annual simple interest rate. 13.2416%. And then if we round to the nearest tenth of 1%, right there, 4 is less than 5, so we round down, and we would get 13.2% on that one. But notice that this Y value, this interest rate, this simple interest rate for the year, is always going to be a little bit larger than the stated interest rate at the beginning. Y will be larger than R, but not a whole lot larger. All right, let's take a look at the calculator function that works with this pretty well. The big difference with the calculator, and you learned this last time, is that the calculator wants you to enter in the percents. I think the variable is I%. So if you want to calculate Y, now I'm going to say Y as a percent this time. There's this calculator function that looks like it has a filled in triangle here, and then it's EFF. And whenever you have that little symbol there, it means convert to. I think we've used one function on the calculator where this sign appeared, and it was convert to fraction. This one is convert to effective annual yield. So this is directly related to that Y. And you need the two numbers. The calculator knows that if you're going to calculate an effective annual yield, you have to give the R and the N. So the R comes first, but as a percentage. So R as a percentage is what goes in the first spot. And then the N value goes in the second spot. So if we wanted to do our problem using this calculator function, the correct numbers to type in would be I as a percent, so it's the 12.5, and then a comma, and then the value of N. Now the big difference is that the answer it's going to report will be a percentage as opposed to a decimal. All right, let's take a look. This function is in the finance menu. So we're going to go to apps, and then we're going to go to the finance menu. Now, don't hit TVM solver here, because the command we're looking for is in the finance menu. So apps, and then finance, number 1, and it's in this menu. And if you see next to number 7, there's a down arrow, and that means that there's a lot more stuff down there. So I'm going to scroll down till I see the function that looks like the one I'm after. There it is. See it? Convert to effective. It's option C. All right, so I'm going to hit the number C or hit enter here. It goes to my home screen, and then I type in 12.5, and then the comma. I forgot where the comma is. It's right above the number 7. And then, but notice this number here does not need to be converted any longer. It's already in that form. So this is a percent. The calculator works differently than our formulas. And if we round to the nearest tenth of 1%, as before, 13.2%. So you can use the calculator function there, or you can use the formula. But notice the numbers, if I can get them both on here, are exactly the same. No matter whether you use the formula or whether you use the special calculator function. All right, so the original problem that I told you about was one where we use the effective annual yield because it allows us to compare two different accounts to determine which one would be the most Well, the one that gives us the most money at the end. Which one gives us an actual yearly interest rate that's higher? And here's an example of what I'm talking about here. Here you have two different accounts. They have about the same interest rate, 5 versus 5.25. One of the accounts is compounded monthly, and the other one is compounded a few number of times. So this one has a higher rate than the first one, but the first one has a higher compounding factor. So what we do is we put both of these through the effective annual yield formula and compare the two results. The one that's the highest is the one that we would choose. All right, so you can either use effective annual yield with 5 and 12, okay, compounded monthly, compounded quarterly, and then the interest rate is 5%, where here it's 5.25. So if you like using those calculator functions, then I would say just go ahead and use that function convert to effective as we used it before, and compare the two numbers. Whatever the higher rate is, that's the one you choose. All right, so I'll let you do that, and I'm going to run through the formula just so you have more examples to look at after class. 1 plus 0.05 divided by 12 to the 12 minus 1 versus y equals 1 plus 0.0525 divided by 4 to the 4th minus 1. So if you get good at this, then I just recalled the things that I typed before. So 5 and 12. And the other one is 5.25 and 4. And there they are, both on the screen pretty quickly. The calculator, takes no time at all. So the effective annual yield, 5 and 12. I'm going to round this one to the nearest, it says 1/10 of a percent. So to right there, this one is 5.1. I don't have to convert this one because it's already as a percent. And the other one is 5.354266737, or 5.4. Okay, so you can clearly see that the higher number is 5.4. So this one here is the better investment. You're going to make more because you get a higher yearly interest rate. If you punch this one into the calculator, you're going to get 0.051161897888. And if you plug this one into the calculator, you're going to get 0.053542666737. All right, really, we need to round to the nearest 1/10 of 1%, which on the decimal, it's the thousandths place. And of course, you don't have to use both methods like I did. One method will do.